This is the Pre-Calculus Chapter 6 test review. Write the augmented matrix for the system of linear equations. When you write an augmented matrix, you're going to write your matrix A, which is the stuff in front of the equal sign, augment it with matrix B, which is the information that is to the right of your equation. Now, when you do this, anything that has variables does need to be to the left. Anything that does not have variables does need to be to the right. And you're just going to write your coefficients in front of those variables. You will not write the variables with them. So all the x's need to be in a column together. All the y's need to be in a column together. And then you are going to augment with what the equations equal. So this will be your augmented matrix. Solve the system of equations. Now, if you have 3 variables and you have 3 equations, it is possible to have no solution, infinitely many solutions, or to have exactly one solution. Now, if you know you're only going to have exactly one solution, you can solve the system of equations using the inverse method. So you can do matrix A, do the inverse of that times matrix B. You can use Cramer's rule, or you can augment and do the reduced row echelon form. Since we do not know if there's going to be exactly one solution to this, there could be infinitely many or there could be no solutions, I'm going to go ahead and augment. So again, you're going to start with the coefficients of your 3 equations, and you're going to augment it with what your equations equal. Now remember, to put this into your calculator, if you have a TI-84 or an 83, you would hit second and then that X inverse button, which has matrix above it. You would go over to edit, you would select matrix A, you would say that the left part of it is a 3 by 3 matrix, and then you would input the information. Then you would hit second mode or second quit to go home. You would hit second matrix again, go over to edit, select matrix B. This one is a 3 by 1 matrix. You would then input your data and again hit second quit. It is important that you hit second quit, otherwise it's going to try to input a matrix inside your other matrix, and that's not going to be good. To augment, you would hit second matrix, go over to math. You were going to go down and select augment or option 7. You would hit, and it's going to say augment, it's going to have a left parenthesis on your screen. Then you would hit second matrix again. You would select matrix A out of names. You would hit comma, hit second matrix again, select matrix B. You're going to close that right parenthesis, and then you're going to hit the store button. That's the button right above on. And then you would go back up, hit second matrix again, select matrix C this time and hit enter. And that's going to give you your augmented matrix. It's not going to show you the dotted line that you put in there, but it will be in there. Once you have augmented your matrix, you can hit second matrix again, go over to math, and we want to put this in the reduced row echelon form, or RREF. And if you scroll down, it's going to be option B. You want to do the reduced row echelon form of matrix C, because that's where you just store this augmented matrix. So you're going to hit second matrix, select matrix C, close your right parenthesis and hit enter, and it's going to give you that our reduced row echelon form of this is 1, 0, 0, 5, 0, 1, 0, 1, and 0, 0, 1, 1. Now, this is your X, your Y, and your Z column. So my X value, because I have a 1 under the X, is equal to 5. My Y value is equal to 1. I'm sorry, I'm looking at the wrong one. So if we do this, our answers are actually -24, -13, and -18. I was looking at the wrong problem. So our X value in this case will be 24. Our Y value will be -13, and our Z value will be -18. 3 families ordered meals of hamburgers, french fries, and drinks. The items they ordered and their bill totals are shown below. Write a system of equations to determine the cost of each item. So we have 6 hamburgers plus 5 french fries plus 5 drinks for the first family, and that's going to cost them $55. We have 2 hamburgers, 1 french fry, and 1 drink for the second person. That's going to be $15. And we have 1 hamburger, 3 french fries, and 2 drinks for the next people, and that's going to cost them $18. Now again, you can choose this to solve it in any method that you want. We know there's going to be one solution. So if you want to do your inverse, you could do matrix A, which would just be your coefficients. So you could do, if this is matrix A, matrix B would be 55, 15, and 18. One option is to do matrix inverse of matrix A times matrix B, and that'll give you solutions. You can augment A and B together and do the reduced row echelon form of the augmented matrix. That's another option. Or you can do Cramer's rule. Whichever method that you choose, I chose to augment. So we have 6, 5, 5, 2, 1, 1, 1, 3, 2. And then our solutions are 55, 15, and 18. Remember, if you do that reduced row echelon form, you are going to end up with 1, 0, 0, 0, 1, 0, and 0, 0, 1 with 5, 3, and 2. And that first column was for hamburgers. The second one was for french fries, and the third one was for drinks. So the first one will be hamburgers. So we know there are 5 hamburgers. The second one was french fries. So we know there were $3 for french fries, $5 for hamburgers. And the last one was drinks. So we know that drinks will cost $2. Whichever method that you choose, you should get the same answer. This is going to be another solve a system of equations. I'm going to augment again because, once again, we do not know if there will be one solution, infinitely many solutions, or no solutions. So matrix A, augment with matrix B. And again, if you go back to that second example one here, it tells you how to put all of this into your calculator. If we do that reduced row echelon form for this matrix, you are going to end up with 1, 0, -5, and -3, 0, 1, -4, and 1, and 0, 0, 0, 0. Now, if you ended up with 0, 0, 0, and a number over here that is not 0, then that means there are no solutions. But if that whole bottom row is all zeros, that means there are infinitely many solutions. Now you need to figure out what those solutions are. So this is x, y, and z. So our first equation is going to be x minus 5z is equal to -3. Our second equation is going to be 1y minus 4z is equal to 1. And our last one, because they're all zeros, z is just equal to z. So it doesn't matter what z value you plug in, everything else will just depend on that. For the first one, you're going to get the x by itself. So we're going to add that 5z to the other side. So we know that x is equal to 5z minus 3. On the next equation, you're going to add the 4z to the other side to get the y by itself. And we'll have 4z is equal to 1. And we're still left with z equals z. So our solution, this should be a plus, will look like this. Again, if that bottom row is not all zeros the whole way across, even the solution, then that will be, if you have zeros on the left but not a zero on the right, that would be no solution. Different point values are awarded for different shots in basketball. Use the information to determine the total amount of points scored by each player. So Ray shot 51 free throws, 38 two-pointers, and 22 three-pointers. And we know a free throw is worth 1, a two-pointer is worth 2, and a three-pointer is worth 3. So we're taking this information, and to find the total, we are going to need to multiply. So if this is matrix A, and this is matrix B, A is a 3 by 3 matrix. B is a 3 by 1 matrix. Remember, to multiply matrices, these two numbers have to be exactly the same. And your resulting matrix will have the dimensions of the outside too. So 3 and 3 are the same. Our resulting matrix will be a 3 by 1 matrix. We have points here, and then we're going to have the players down here. So Ray, Chris, and Jerry. So if we do matrix A, plug that into your calculator, matrix B, plug that into your calculator, and multiply, you will see that we're going to end up with 183, 176, and 179. So Ray will score 183 points, Chris will score 176 points that season, and Jerry will score 179 points. Determine whether A and B are inverse matrices. To check this, you need to do matrix A times matrix B, and you need to end up with the identity matrix. For a 2 by 2 matrix, remember the identity matrix will be 1, 0, 0, 1. And you need to do matrix B times matrix A, and that also needs to be the identity matrix. Now you can type this directly into your calculator, put matrix A in, put in matrix B, you do matrix A times matrix B, and you will see the first one looks like this. And then we can do matrix B times matrix A, and you will get this. So these are, in fact, inverse matrices. Given the following matrix, you need to find the determinant and you need to find the inverse matrix. And it does say you must show your work. So on a matrix, remember we have A, B, C, and D. To find the determinant of a matrix, you're going to do A times D minus C times B, or 2 times negative 2 minus negative 2 times negative 3. This is going to give me negative 4 minus 6, or negative 10. So our determinant is going to be negative 10. To find the inverse matrix, you're going to do 1 over the determinant of your matrix times, what you're going to do in this case is you are going to flip your D and your A, and you're going to change the signs for your B and your C. So we have 1 over negative 10. So our inverse matrix equals this. So 1 over negative 10, we already found the determinant. We're going to switch the values for D and A. And then for B and C, we're just going to change the signs. Now we're just going to take that negative 1/10 and we are going to distribute. So negative times negative makes a positive 2 over 10. Next will be negative 3 over 10, negative 2 over 10, and negative 2 over 10. And if we want to reduce that matrix, this will give us 1/5, negative 3/10, negative 1/5, and negative 1/5 as our solution. Find the determinant of the matrix. You must show your work. So remember, the stuff at the top is going to be what's left outside. So we're going to start with negative 1, and we're going to find the determinant of, since I used the negative 1, we're going to ignore that column for right now, and you're going to write down all the other elements. So 0, 3, 1, and negative 2. The next one is always minus, and it's minus the next value across the top, which is negative 2. Because we use the negative 2, we're going to ignore that column, and we're going to write the others. And then it's going to be plus the last one. We're going to ignore that last column, so we're left with 4, 0, negative 3, and 1. Now this means find the determinant. This is the exact same thing we just done on the last one. This is A, B, C, and D. And remember, to find the determinant, it's going to be AD minus CB. So I'm going to do negative 1 times A times D minus C times B. Minus a negative, I can turn that to a plus. For the next one, A times D minus C times B. And for the last one, A times D minus C times B. Now, 0 times negative 2 is 0, minus 3, negative 8, plus 9, and 4 minus 0. Or negative 1 times negative 3, 2 times 1, and 1 times 4, which will give us 3 plus 2 plus 4, or our determinant is 9. Now you do have to show your work on this problem for your test, but an easy way to check to make sure you got the correct answer is just plug the matrix in, find the determinant on your calculator, and make sure you got the correct answer. Use an inverse matrix to solve the systems of equations if possible. Make sure to show that inverse matrix. So when you're doing an inverse matrix, you're going to take your matrix A, which is the coefficients in front of your variables. So our matrix A will be 1, negative 2, negative 3, 2, negative 3, and 4, 1, negative 8, and 2. And you're going to take your matrix B, which is 0, 11, and negative 1. First thing you're going to do is make sure you can find the inverse of matrix A. If you can, you're going to write it down. So you would just input matrix A into your calculator, do the inverse, which is the same button you use as matrix. You would select matrix 1, hit the inverse button, and hit enter. And it is going to give it to you, if it's possible, most likely in a bunch of decimals. Once it's in the decimal form, you can hit alpha, or the green button, hit y equals, and go down and select option 4, which is fractions to decimals or decimals to fractions. Hit enter, and then hit enter again, and it will convert those decimals to fractions for you. So they are easier to write down. So we have 2/5, 28 over 65, negative 17 over 65, 0, 1/13, negative 2/13, negative 1/5, 6 65ths, and 1 over 65. So it does say show your inverse matrix. We did that. And now all you have to do is your inverse matrix A times matrix B. You can do all that in your calculator at the exact same time. Multiply, and you should get 5, 1, and 1, which means our x value is 5, our y value is 1, and our z value is 1. Now you can also solve problems using Cramer's rule. In this case, they will tell you to use Cramer's rule, and you could only do this if a unique solution exists. So like at the beginning, I told you you could use any of the 3 methods that you wanted, only if you know there's only going to be one solution. So to do this, we know that matrix A is just our coefficients. So it's the 5, 4, negative 1, and negative 4. Matrix B is 7 and negative 3. We are also going to have to find matrix A sub 1 and matrix A sub 2. Now in A sub 1, that means you're going to take the first column and you're going to replace it with matrix B. So for matrix A, I'm going to erase that first column. I'm going to leave the second column alone, and I'm going to replace the first column with matrix B. On A2, I'm going to leave the first column alone, and I'm going to replace the second column with matrix B. From here, I need to find the determinant of A, the determinant of A sub 1, and the determinant of A sub 2. Remember, to find the determinant, it's AD minus CB. So we're going to do 5 times negative 4 minus negative 1 times 4. The next one we'll do 7 times negative 4 minus negative 3 times negative 4. And A sub 2 will be 5 times negative 3 minus negative 1 times 7. Or the determinant for matrix A will be negative 16. The determinant of A sub 1 will be negative 16. And the determinant of A sub 2 will be negative 8. Now using the Cramer's rule, we know x is the determinant of a sub 1 divided by the determinant of a, and y is the determinant of a sub 2 divided by the determinant of a. So for the first one, we're going to do negative 16 divided by negative 16, which would give us a 1. And for the second one, we're going to have negative 8 divided by negative 16, which will give us a 1/2. So our solution will be 1 and 1/2.